Okay, on the top of page 12, what we are now going to do is focus on some composition functions that have inner function values with a variable, whereas on the previous page, we could actually solve for the value. So our strategies here, again, will be to make our equation of the inner function, make an equation, and we're going to set it equal to theta, just like we did in the previous problem. And then we'll draw our reference triangle. And we're going to focus, when we have these variables, only on the first quadrant. And the reason why is because we don't know what x is, and eventually the value will resolve itself. So we do not know x. So the problem will eventually resolve. Meaning if there is a negative value, it'll come up in the answer. So we will find the missing side, again, using the Pythagorean theorem. And then what you need to remember is that you will have a variable in the answer. You will not have a whole numerical answer like we did in the previous problems. So what we'll do is state the ratio of the outer function using the reference triangle drawn in the first quadrant. And just so you know, you do not have to rationalize the denominator. So just to make it easier for yourself, do not rationalize. You can leave a radical in the denominator. So if this is an opportunity to do it, do it. Okay? So let's take a look at what we've got here. So you notice there's a variable in here. And based on our steps up at the top, we're going to take this inside, just like we did on the previous page. We're going to make it an equation by setting it equal to theta. So this whole thing right here is our theta. So we'll say arctangent of the square root of 3 over 5x is equal to theta. Multiply both sides by tangent. Okay? And then what we want to do is draw our reference triangle in the first quadrant as stated in our directions. Remember, this is only when you have a variable, okay, in your problem. So if you look at all of these, variable, 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 okay? So tangent is y over, this whole thing is your x. So now we need to solve for r because we're looking for the cosecant. And what you have to remember is cosecant is going to be r over y. So we need our r value, okay? So this is x squared plus y squared is equal to r squared. So this is 25x squared plus, I want to make sure I don't make that mistake again, this is 3 is equal to r squared. To find r, we take the square root, so r is equal to the square root of 25x squared plus 3. So you see here, we're not going to get rid of this x. It's going to be in terms of a variable, as stated in step number 3 of our strategy. So this is what we're looking for. This is our r. This is our y. So we have the cosecant of theta is equal to the square root of 25x squared plus 3 over the square root of 3. Or you could write it all under one big radical. Either answer is sufficient. Most often you'll see it like this though because you won't have two radicals.